Welcome to the beginner level course on Introduction to Version Control System using Git and GitHub, where our goal is to make the version control system learning experience easy to learn for people from every walks of life. Four key concepts throughout the course are explained visually to enable our student grasp the technical concepts quickly and effectively. The lab portion covers the key concepts of the version control system, creating a Git account and installing the Git application to your PC, creating remote repositories in GitHub, going through the features to look at before creating your first repository. We will look at creating the repository files using the online web interface and learn the differences between Git and GitHub practically, committing changes to the file, performing revisions of the commits. Then we will see the Git bash command line interface, how to add local repositories, push and pull the repository files, learning the concepts of staging area in terms of local repository, adding collaborators to your repository and accepting a collaborator invite is also covered in the lab exercises. Next, we will also learn to analyze the logs and status of commits performed in order to track the changes. After that, we will move to the core concepts of branching and see some branching models commonly used in version control. Hi, in this lecture, we will see the basic working flow for any version control system. Version control systems have an online server, usually called a repository, which holds the latest version of the software that you are working on. Here is the diagram. You can see that a user can access the older version v1.1 of a file. This accessing is known as pull in version control. After this, the user performs some working on the file and then wants to upload it. The new save changes is known as commit, and the uploading process of this new file is called push. Now, this newer version of the file is uploaded in the repository. The version control detects it as an updated version of the file and save it as v1.2 in the repository. Here are the basic building blocks of a version control system. The most basic building block of a version control is a repository. Then comes the commit process and the local and remote repositories. First in this list is the repository. It is similar to a database where your version control system stores all the version and metadata that accumulate in the course of your project. To get a repository on your local machine, there are two ways. First case might be if you have a project locally on your computer that is not yet under version control. You can initialize a new repository for this project. Second, if you are getting on board of a project that's already running, chances are there is a repository on a remote server. You will then probably be provided with a URL to this repository that you will then download or copy to your local computer. Once you have set a local repository, you can start working on your files, modify, delete, add, copy, or rename. Just make any changes necessary to move your project forward. Now, when you feel you have reached a noteworthy state that you have to consider version control again, then it's time to wrap up your changes in a commit. A commit is a wrapper for a specific set of changes. The author of a commit has to commit what he did in a short commit message. This helps other people and himself to understand later what his intention was when making these changes. Whenever you make changes to a project and commit it, the file is stored at multiple locations. First is your own local storage or say local repository. Once you commit it, the files get uploaded to a remote server, which is the remote repository. This remote repository can be used by other team members for them to see what changes you have made to the project. Or using the remote repository, if you pull a file, you can have the track of that file. Hi, welcome to the second section, Introduction to Git for the Version Control course. In this lecture, we will see what Git is. Git is a software tool and is a distributed version control and source code management system with an emphasis on speed. Git was initially designed and developed by Linus Torvald for Linux kernel development. Git is a free software distributed under the terms of the General Public License version. In a distributed version control system, Git focuses at enabling the share of code or the source code available across all team members. Like here, the three developers A, B, and C who are working together on a software package must be able to share their files so that it is ensured that they are always working on updated codes. The key difference of the distributed version control system as compared to the traditional version control system is that all developers have the entire code available on their local systems. They try to keep the entire code updated all the time. Now, it is the responsibility of the distributed version control server, which is Git in our case, to ensure that all the developers have the latest version updated on their local machines as that on the central distributed repository. It then allows the developers to have a peer-to-peer file sharing enabled with regular updates of the source codes. For instance, developer A modifies the code, makes some changes to a source code which is available in his local PC. Once he is done with the final updates to his code, he commits the changes to the distributed server. This newly committed file is now present in the distributed server. The key role of such a distributed system in this case is to intimate the other developers B and C about the new available versions and also update them in their local systems so that all are up to date with the latest versions of the source code. This is what Git does. It redistributes the changes to all the users connected to a common repository. Let's see in a bit detail on how this distributed version control system works. The developer at different locations start working and they make a copy of their source codes in a local environment. This local environment can be updated manually, means that anyone having access to the local repository can manually update the codes at their location. Then the codes from the local repository is pushed out into the Git repository. So the local repository always pushes out the latest codes. And then from the Git repository, you are then able to pull the latest updates. So the Git repository becomes the central repository for you. And then you can push updates and pull updates from this central repository. In this way, each developer connect to the Git repository has always the latest updates of the codes. As we know now what is Git, Git is a distributed version control system used for source code management. GitHub is a remote server for this source code management. All the team members of a project can connect to a Git server for this specific repository using GitHub. GitHub is designed as a Git repository hosting service and is exclusively cloud-based. You can share your code with others, giving them the power to make revision or edits. Let's talk about Git versus GitHub. Git is a software tool, whereas GitHub is a service. You install software locally on your computer system, whereas GitHub, being a service, is hosted on a web platform. Git is a software that is used to actually manage different versions of the source code, whereas GitHub is used to have a copy of the local repository stored on the website where it is hosted. Git provides a command line interface tool that allows you to interact with your files, whereas the GitHub has a graphical interface that allows you to check in and check out the files. Now that we have understood what is Git, let's learn some of the Git features. Listed here are few important features of Git, in which we have the fork and clone, which is basically making copies of your project or the source code. Adding collaboration allows you to add members to the project. Branches associated with the project hierarchy. Then is the Git rebase, which actually restructures your overall project hierarchy. Also, you can pull or say download the latest updated source code from the remote server. Let's discuss each one of them. Git allows you to fork an open source repository. When you fork a repository, you create a copy of the original repository, but the repository remains on your GitHub account. Whereas when you clone a repository, the repository is copied onto your local machine with the help of Git. Let's say you are interested in a project and want to fork it so that you can have the same project file in your repository. You can fork it from the repository and the same program file gets forked in your own repository. Once the forked project is available in your own repository, you can then clone it to the local repository. I'm confused. There are some errors in my code which needs to be fixed. Add me as a collaborator on GitHub and also give the permission. Ever happened that some of your colleagues get stuck in a code facing some errors or bug? Collaborator features allow you to add members as collaborators so that they can contribute to the project. GitHub allows you to work with users from all over the world at any given time. Collaborators are GitHub users who are given permission to edit a repository owned by someone else or in a sample project having multiple stakeholders. The default branch name in Git is master. As you start making commits, you are given a master branch that points to the last commit you made. Every time you commit, the master branch pointer moves forward automatically. Branches serve as an abstraction for the commit process. You can think of them as a way to request a brand new working directory, staging area, and project history. New commits are recorded in the history for the current branch, which results in a fork in the history of the project. You can create a new branch and build the new feature on that branch. By default, you always work on the master branch. The circles on the branch represents various commits made on the branch. Branch in Git is used to keep your changes until they are ready. The diagram shows there are two new branches. You can either keep the same changes and develop the features you want separately. After you develop them completely, you can merge the newly created branches to the master branch. Merging in Git is a way of putting a forked history back together again. The git merge commands lets you take the independent lines of development created by Git branch and integrate them into a single branch. Merge commits are unique against other commits in the fact that they have two parent commits. When creating a merge commit, Git will attempt to automatically merge the separate histories for you. If Git encounters a piece of data that is changed in both histories, it will be unable to automatically combine them. This scenario is a version control conflict, and Git will need users' intervention to continue. Rebase is the process of moving or combining a sequence of commits to a new base commit. Rebasing is most useful and easily visualized in the context of a feature branching workflow. Starting with the full tree, we have a stale branch in red of a master branch. It can be seen that the branch is stale because it's missing the recent commits from master in blue. When we run git rebase, It first will rewind both branches back to the first point when their commit history matches in gray. From this point, Git Rebase will fast forward through the commits on the master branch and apply them to the stale branch. Finally, Git Rebase replays the commits from the stale branch. The resulting tree is as if you just created a new branch of master and made your commits. In doing so, Git Rebase facilitates a clean merge. During the pull process, all the developers having a collaborator relationship can fetch the files from the remote repository. During this process, a local copy of the original file is saved to the developer's local PC. And after the required changes, it can be committed back as an updated version of the repository kept at a remote location. In this lecture, we will look at the workflow of the Git. In order to understand it, we must be very clear about the Git architecture first. The working directory is the current folder where you are working on your Git project. This is your working directory where you store your files. And then you add your file to a staging area where you are ready to update your program file back on the main branch of your project repository. Once you are done making the changes, you push out all the changes onto your local repository. This will commit your updated files and get them ready to synchronize with the services, which is Git in our case. And then the services push the files to the remote repository, which is GitHub in this case. Later on, when you work on the file again before writing any code further on your local machine, you first pull the file from the remote repository to the local repository and then make updates to the previous file and then brought to the working directory so that it is ensured that you always get the latest version of the file from the remote repository. This makes sure that even if other team members are working on the same code and they have made their updates, you always have the updated version. One thing, if you are working on some new features within your project, you can create branches, merge them with the main source code. This enables you to do lots of creative things in your project without disturbing or affecting the main code. Hi, and welcome to the lab session of GitHub. In this lab session, we will learn how to create and configure a new account on GitHub and create your repositories using this distributed version control system and manage our electronic files. Go to the Google and type GitHub and click on this link here. Once you are on the github.com, you will see this screen in front of you. Now here we have a sign up screen in front of us. Select a username of your choice for your account. If your selected username is available for you in a GitHub account, it will show a green tick mark, just as in my case, where I have selected my username as skill-curve. If I type in the complete name, you see I delete and type it directly. So it gives a red warning sign that this username is not available. You have the option to change your username after the account is created, but it is recommended to select the best option right here. Next, you have to enter your email ID. So I enter here my email ID, which is git@skillcurve.com. Next, you choose a password for your new account. Once you are done with all the credentials, you can click on the sign up button. So here your account is being created, asking to save the password. I am okay to go with it. Once your account is created, you will be asked to verify your account through email and also by solving a quick puzzle here, just to ensure that you are a human and not a robot. Here is a spiral galaxy selection puzzle. Just select this one and go. Done successfully. If you are interested in any updates or so, you can check this button here. And then let's move on with joining the free plan account. So here we have successfully created our account, but just to let you know, we haven't verified our email address yet. So here are some of the questions GitHub asks you to maintain your profile. Let's answer them. What kind of work do you do? So I am a software engineer, or you can select any other option depending upon your account case. So I select this as I write codes. Then it asks for how much programming experience do you have. Well, you can choose your best option that suits you. I will move on with a little option. Moving on forward, it asks you why you are planning to use the GitHub. So there are many options again. It depends on your choice of option. Like either you are looking to host a repository, learn Git and GitHub, or either learn to code, and multiple options in there. I am interested in hosting my project repositories, so I will go for the host project option. If you are interested in any kind of languages or frameworks, you can type them here so that GitHub will then recommend you some projects relevant to your choice of interest. I will leave it unchecked at the moment and complete the setup. Once the setup is completed, you will see this page. Now we have to verify our email address by going to my inbox mail on git@skillcurve.com. In order to get the complete access of GitHub, you need to verify your ID. So let's move and perform this task. So here we are. We have received an email from GitHub asking to verify the email address. Let's click on the verify email address link. As you click on it, you will be directed to the login page. Log in with your email and password. And then here is the main page and it says email was verified. Let's explore what options we have. Here are the three options. Either you start by creating a repository or an organization, or simply start learning. Let's skip this for now and then we will explore these later. So here is the main home page of your GitHub account after successfully creating your account. In the next lab exercises, we will be looking at creating new repositories, pushing and pulling the files, and performing different actions. In this lab exercise, we will learn how to install Git on your PC or any laptop. Type in Git download on Google, you will see these searches appear on your screen. Click on the first link and you will be redirected to this download page. Here it automatically detects your operating system. Like in my case, it's Windows 10. Once you click on the Windows, an automatic download starts. It will download the latest version for you, so no need to worry for that. Alright, the setup file has been downloaded. Let's begin the installation procedure. Allow it to run the setup. So begin by clicking on Next. This is the default path of installation. If you want some other path to install Git, you can change it here. We are okay with the path, so click Next. Here are few options that you see. These are the components selection that you need to install with the Git. This is the simple option to select just in case you need the GitHub icons on the desktop for your ease of access. Next is the integration of Git with Windows Explorer. Here the two options are for your daily actions that you will perform using Git. Using the bash, you will be able to use the command line interface to write and execute your commands. Similarly, Git GUI is an advanced version of it where you have access to all actions using a user interface. Git LFS is a Git extension that helps you save some space when you are dealing with some large file size. I would recommend you to enable it unless you have a specific reason to disable it. Associate.gitconfig files with default text editor should be enabled as it allows you to check into the config files easily. Associate.sh files to be run with bash unless you want your shell scripts associated with Windows Bash, you will have to check that. Okay, use a true type font in all console windows. This can be helpful to you if you use Unicode characters in your file names. Check daily for updates is not recommended as it uses extra bits of your computer resources, making it slow. Alright, so before moving on further, just ensure that these two options, Git Bash and Git GUI, are checked. Then we click Next. This is simply the name that will appear in your search bar or in the Start menu. If you want to change it, you can change it by editing. As we are okay with it, click Next. And then you go all the way to complete the installation. Okay, so now the installation is completed. We will uncheck the Release Notes view and check the Launch Git Bash option as we want to run it and click on Next. Then this is the first screen which you see when you have installed the Git on your PC. To check the version of the installed Git on your PC, type git-version. So the latest version available today, 2.29.1, is installed. To explore some other general options, you can type Git help and it will provide you with a list of options. In our next lab session, we will use the console to commit, create repositories, push and pull, and perform other actions from a local PC. In this lab exercise, we will learn how to install Git on your PC or any laptop with Linux operating system. Here I am on Ubuntu-based operating system. The first step before you install the Git on Linux is open the terminal command line. Before we proceed, to check if Git is installed, type in git-version. Here you can see that the Git is not installed currently. Before installing Git, your APT must be up to date and upgraded. So I will first update the APT with command sudo apt update. It will take less time and update the APT. Next, we will upgrade APT so that it is in line with the latest version. This takes much longer than the update command, usually around 20 minutes or so. Alright, so the APT is now updated and upgraded. Now we will move to the installation of Git. To install it, write the command sudo apt-get install git. This will begin downloading and installing the Git. Now it asks for the permission for additional storage. Type Y for yes and continue. After a while, you have Git installed on your PC. Now to check it, we will type in git-version. So here you can see that the latest version 2.25.1 is installed. So this is how you install Git on the Linux operating system. Our lab exercise throughout the sessions is based on Windows operating system, but not to worry because once on Linux you have installed the Git, rest all the procedure is same. This is another developer PC on which we have just installed the Git setup. On this PC, we want to maintain the main repository, which is on our skill curve account. So for this, we need to give those credentials to our locally installed Git on our PC so that it recognizes our account. In order to check if our locally installed Git is configured or integrated to an account, we write git config -- global user.name. And when you press enter, you see that it does not give any output. Similarly, if I write down git config -- global user.email, you see there's still no output. It means we need to configure our account. Configuring your account is a one-time activity. If our Git was configured or linked to some account, it would have given the username and email as an output, which we see by the end of this lab session. You can type clear to clear the screen. Let's configure our account to the credentials of our skill curve account. We write down git config -- global user.name skill curve. If you remember, skill curve is the username that we just created while making our account on GitHub. Next, we assign the email ID like git config -- global user.email, git@skillcurve.com. Now we will check if we have properly assigned the username and email address. To do this, we simply type in git config -- global user.name. Now we see that it shows the username. Next, we type git config -- global user.email. Similarly, it shows the email address we have assigned. This means that we have successfully configured the Git account on our local PC. Now you can pull, copy, clone, push the repositories and files to this account. Here you might be wondering that in this way anyone can access others' username and email ID and commit to their account. But it is not that way. When you will start to perform actions like pull, commit or others, you will be asked for an authentication password to authenticate your device with the account. We will see that in our future lab exercises. In this lab exercise, we will look at creating a new remote repository with your account. We will do this activity on the GitHub account we just created and using the web GUI of GitHub. Alright, so this is the main screen which you see once when you log in to your GitHub account. After that, you go to the Create Repository option here. So it then asks you for a repository name. Let's create the account with the name My First Project. Or it can be any other name of your choice. If the same name repository already exists in your account, it will not show the green tick mark. Next is the description, which is optional. You can add it to describe what your repository is all about. So let me write down as this is my first repository on GitHub. Next is the option for public or private. This is usually the selection that either you want your repository to be public or either private. I am good to go with the public option as this repository will in future be shared with my students. Here are some of the repositories options to initialize your repository with. Like if you want to add a README file, which you have seen usually with most of the public available open source codes or software setups. These usually describe how to use a particular code or a software, so it is a good option to go with including it in your repository. Next is adding a .git ignore file This is nothing but a simple list of files which we can ignore while making changes to our main folder, or while performing commits and other such actions. This part we will cover in detail later. And then you have the option for adding a license. This is usually when you generate a license in terms of use or your open source code. For now, we are okay to go with the README file only. Click on Create Repository. So here the repository is created. Once it is created, you will see a screen like this. As you can see, here is the branch indication. Right now the branch is single and the repository is created on the main branch named main. It also shows that we have one branch at the moment. We currently have one file in the repository, and that's the README file with a .md extension, which is basically the markdown language so that you can see such files in an HTML view. And this is your initial commit. So I hope you have now learned how to create a Git remote repository, and in our next lab exercise, we will look at how to commit a file in a remote repository. In this lab exercise, we will see how to create a new file inside a repository using the GitHub web interface and commit that file in the repository. Here you can see it shows one commit, which is because of the README file here that we added during the creation of the repository. As a fact that we have added it in our repository, it is counted as a single commit. In the same way, we will be adding and editing some files over here. This is the option for code cloning. We will explore it later once we have some files in our repository to work on. Here is the Add File dropdown. You have two options. One is to create a new file, and other one is to update a file you already have in your drive with you. Now we are actually interested in creating a new file, and we will see the entire work process behind the GitHub. Here we create a new file. It then asks you for the name of the file. Let's name it as an activity sheet. And then hit enter. This is the text editor for us, and here I am going to use a text file as an example. It can be any source code or any other document, but to make the process simpler, we will take a basic text file containing some basic activities mentioned in it. The basic idea here is to understand the basic terminologies we have studied in the theory section and to understand their working. Let's say this is an activity sheet for different team members working with us. We have John. He has to create a web template for the website. His deadline is October 20, 2020. Then we have a second member, Michael, who is to design a web on WordPress. By October 25, 2020. Next we have Tom. And he was assigned a task to maintain the source codes and his deadline is October 30, 2020. To make it more understandable, let me add titles at the top of the file, the serial number, names, task, deadline, and quickly let me format the file so that it gives a clear view. We are done with the file now. We can leave the title as Create Activity Sheet, and below we can give some description like task assigned. Then we commit the new file. We can now see here that the file is added. Here is the activity sheet text file which appears in the list, and the commit number now changes to 2. Point to notice here is that the commit number does not mean the number of files. Don't get confused that the number of files are 2. So the commit number is also 2. Commit actually means the number of revisions or updates you have performed in your repository files. Let's see this. I go back to my activity sheet. I want to edit this file, and let's say we have a 4th member to be added in our list. So we have Salman, and his task is to review the sales document of the company. And his deadline is October 29, 2020. Add a description to the commit title. Updated activity sheet as Salman's activity updated. Let me change activity to task. This is more relatable. And then click on commit changes. The file is now updated and saved. When we go back to my first project homepage, you see here that the commit number changes to 3. And the files are still 2. But with the activity sheet, you can see the updated title to the updated activity sheet, where we added the 4th member and his assigned task. When I go back to commit history, it will show you all the commit changes we have made starting from the initial commit. Later we created an activity sheet and then we updated the same activity sheet. Now this history is viewable, like if you click on any of the commit history, previous version, you can see what was the file it looked like before the later commit performed after this. So here you can see that it shows that there are 3 names and it does not show the 4th name because that was committed later and saved as another update. If you go back again and look at the latest commit, it shows the 4th name with a plus sign indicating that a row was added as compared to the previous file. So this is how you create a repository and the GitHub keeps track of different versions of your electronic documents. I hope this explanation in the video lecture has cleared your concepts on how to commit a remote repository in your GitHub account. In our next lab session, we will look at how to commit revisions of a file in GitHub. In this lab exercise, we will look at how to revise a file and commit it on GitHub using the web interface. Coming back to our same file, the activity sheet, Let's say the boss of the company wants to see the progress status of these tasks as well. So we go to the edit option here and add a column ahead of deadline showing status. We can write the status like pending, or a more professional term like in progress for all the tasks that are in progress. After making the changes, we can commit changes. But remember, it is a good practice to write a note title and description so that it helps you remember what changes you have done to your file. It helps you recall what was the last changes made for. I'm going to write here added status column to the sheet. Commit the changes. So here you can see the updated changes. And when I go back to the project home page, it shows now that we have 4 commits. If we go to the commit history, you can see all the revision histories for the created file. When your file was created, made the first change to update the activity sheet, and the next and the last we added a status column to the sheet. Each commit has a unique ID assigned to it which helps to track the version. This is used in the backend of GitHub. You will understand it when we will go to the lab exercises of Git Bash, the command line interface. Let me go back to the file and make some quick changes to the activity sheet. For example, John have completed the task he was assigned, so we mark it as done. And write a commit note that John task status updated. We see that the changes have been saved. When I go back to the project, you can see here that now we have 5 commits. So this commit number is actually associated with the number of revisions performed within the repository. Here is the README file in which you can add some notes or information about the repository. Its detailed description and all that stuff. In the same way, you can edit it here. Right now, we don't want to make any changes to this file, so I will cancel it and come back to the project repository home screen. This brings us to the end of the video lecture, and I hope you have now got an idea on how you can commit revisions of a file and look into the commit history for different versions of the same file. In this lab exercise, we will go through a quick overview of the option contained within the GUI of any project repository. This project has a single branch at the moment with the name main that can be seen here at the left of the branch count indication. Using the code drop-down selection, you can actually download or clone the repository in your own PC directly from GitHub or using the HTTP's SSH link in the Git Bash using command line interface. Using the Add File drop-down, you can add a file from your PC by uploading it or create a new file. By using the option Go to File, you will see this page. And can search for the project files in the repository. Like right now, I have only 2 files in my repository. But what if you have hundreds of files in a single repository? So this search option helps you filter out and navigate to the file you want. For example, I search here by typing activity sheet, and you see only the related search appears in the list below. Then there is a issue tab, which is also known as GitHub's tracker and has its own section in every repository. A title and description describes what the issue is all about. Color-coded labels help you categorize and filter your issues just like labels in email. Then there is a pull request tab. Pull requests are the heart of collaboration on GitHub. When you open a pull request, you are proposing your changes and requesting that someone review and pull in your contribution and merge them into their branch. Pull request shows differences of the content from both branches. The changes, additions, and subtractions are shown in green and red. Actions are individual tasks that you can combine to create jobs and customize your workflow. You can create your own actions or use and customize actions shared by the GitHub community. There are some popular services integration available so that you can directly deploy your codes on the required platform. And then there are the project features for organizing the project. The wiki features allow you to add a detailed report type viewable page that you can share publicly. The Insights shows you all the insights related to the analytic reports based on data from your GitHub Enterprise Service instance to help you understand and improve your software delivery processes. Settings are the basic ones like you want to make the repo public or private, transfer ownership of the repository, or add some collaborators to it. This is just a quick overview. We will be looking at each of the options related to our course in next section. In this lecture, we will see how you can actually get a GitHub repository which we have just saved on the newly created account. And then we will implement it practically. So here is our scenario where a developer wants to copy a certain file from the GitHub repository placed somewhere on GitHub. For this example, we will use the same repository we created previously which contained a text file named as activity sheet. This was created under the repository name My First Project. Recalling the activity sheet, it contained the name of team members, their respective tasks, deadlines, and the status of their task. The repository was created for our account, username skillcurve and email ID git@skillcurve.com. The developer in his local PC has the Git bash, the command line interface which we learned to install earlier, we will be using for this and onward exercise. Now this developer actually wants the file activity sheet copied to his local system which is currently available on the GitHub. Once he successfully copies the file, it will then be in his local repository. So how is he going to do that? If you remember this drop-down menu option we discussed earlier under the code option, it has a clone link in HTTPS, SSH and CLI. This link will play the role here for the developer. For the developer to copy the file successfully to his PC, he will need to first get the repository link, which is, in our case, is the one mentioned here. After he has got the link, next he will have to use this HTTPS link to clone the remote repository to his local repository using the git bash command line interface. Let's see this practically. Here we are in the developer system, and currently we are working in the folder located in the directory in C drive on the desktop containing folder named version control system. As you can see at the back of the git bash GUI, it is empty. Write down git clone, the repository name, my first project. Will I get the repository this way? No, this isn't the right way. We haven't located our git bash to the root directory of the repository so far. We need to give it a complete path. So where will we get that complete path from? For that, you will need to go to the GitHub web, and I said earlier, we will talk about this option later. So here under the code dropdown, you will get 3 different options. The HTTPS, SSH, and the GitHub CLI. If you directly copy the CLI command given here, this will also work fine for you, but we will use the HTTPS link. Go to HTTPS, select and copy the link, and then come back to Git bash. Now we will execute the same command, git clone, and then paste the HTTPS link, just copy it. Once we press enter, you see it starts cloning the project. And here it is done cloning. Now if I go back to the folder, you can see here that the folder with the same repository name exists here. This is done using the command line interface. If I go into the folder, you will find the activity sheet and a readme file. This .git folder I will discuss later. Let's open the activity sheet and see if it contains the same content we created. So here we see it's the same file we created. So this is how you can copy a repository and get it to your local repository on your PC or a laptop using the command line interface that is the Git bash. In this lab exercise, we will look at the folders that get cloned once you copy the repository from GitHub. And then we will see how you can check the commit history from the Git bash command line interface. If you remember, we cloned the repository in our desktop folder version control system, and our repository name is my first project. So let's move into that folder by typing cd, which means change directory. You can see the directory changes to the specified folder and it shows main written in brackets. Now this main represents the branch of your current working path that you are using the main branch of the repository. To check the directories inside the repository, you type in dir. It shows these 2 files, the activity sheet and readme file. We can also see a hidden folder here, which the dir command does not show to us. Moving into the .git folder, we see these files. The file important for us is the config file. Let me open it with an editor for you. These are a few variables that GitHub and your local Git uses to locate the files and keeps track of them. Here you see the remote origin path is provided. This shows the link to the centralized repository located on GitHub. And in addition, it also tells you that whatever changes you will make and commit, it will be saved and updated at this URL. Let's go back to the main folder and start Git bash so that we can see how you can actually check the commit history using your local PC, just like we saw commits previously on GitHub web. Let's just have a quick review at the activity sheet in our GitHub account. This is the file we had and we committed it with revisions as well. Here the commit number 5 shows that if you click and go to the commit history of this file, you will find all the commit revisions that are done to this file in particular. But the point is, what if we want to see the commit history not here, but on the command line interface in our Git bash? For this, we go to the Git bash and type down the command git log. Once executed, this will show you all the changes that were made to the file over the period of time. Also, if you see here, it also shows you the author name, that is a skill curve, but no specific email address. Now, this can really create an issue when you have multiple developers on board, as you won't be able to reach out the members with their email addresses to query them related to any bug or issues in the file. This information is unavailable to us due to the fact that the commits were made using the web GUI and not the command line interface. So whenever a member makes a commit from their local PC using the command line interface, the commit history will also show the complete username and email ID of the member who has performed the commit. I hope this gives you a concept on which method to choose to commit a file in order to keep track of them. We will see in our upcoming lab sessions on how to commit a file from your local PC using this command line interface. In this lab exercise, we will see step-by-step sequence to commit the revisions in a file to the local repository and then to the Git repository. Let's begin by opening the activity sheet file in the text editor. Suppose I want to add some more member information to this sheet. I will edit it and add the next person here. So, I have Jerry on my team and he plans the human resources for the company. We assign him a deadline to be October 31st, 2020 and his status is in progress. Now I will save the file here, and should it directly get uploaded on the local and remote Git repository? Let's see. Let me go back to the web console for the Git repository and check if the updates are reflected here inside the activity sheet. Here you can see that the changes did not occur, and if I go back to the project homepage, or you can say the repository homepage, you will find that the sheet shows its last commit here was 2 days ago. So why did the file not upload to the Git repository directly? If you recall our theory lectures, we learned that to commit the file, or maybe say to upload the file on a remote Git repository, the file must first be present in the local repository and then moved to the remote repository. For this, I have started here the Git Bash tool, as I have made some changes to a file which is contained in this folder, so Git Bash can track that change. It's a best practice to run the git status command to see at what present status regarding the local repository you are. Here in the result for git status, you will see a red colored text. This means that the file with the name activity sheet has changed but not added in the local repository. Once you add and move forward, the color changes to green. Let's understand this concept with the help of this block diagram. This flowchart shows a basic workflow of committing a file in the local repository. The file from the working directory is first moved to the staging area. After that, the file is moved to the local repository. For instance, you first make some changes to the file in the working directory and then move it to the staging area. But later realize that the change is not needed, so for that case, you can remove it from the staging area itself. Currently, we are working in the working directory. So to move the file from the working directory to the staging area, we use the command git add. On executing this command, the file is moved to the staging area. From here, the file is moved to the local repository And to do so, we execute the command git commit. Now your file is successfully moved to the local repository. When you want to move it to a remote repository on GitHub, you can use the command git push. So this is how the overall git commit process works. Let's see it practically. Write git add dot. This will add all the files to the staging area. There should be a space before the dot so we can see the command executed without any error. Again, check the status by git status and you can see that the updated file's name is in green color, which means it is added to the staging area. As we are still in the staging area, so the file will not be available to us in the Git repository. Here you can see that still the changes are not reflected yet. Now we have added the file. Next is to commit it to the local repository. For that we write git commit -m and the commit message is in the inverted commas. I will write added Jerry's task as the message and press enter. You see it shows that one file was changed with one insertion. The file is committed to the local repository and not to the remote repository. This we can see by again coming to the web console and refreshing the page. By clicking on the repository homepage. Now if we see the git status, you will find that the message says your branch is ahead of origin by one commit. What does that mean? This is because we are working on the main branch of the repository, and as I have made the changes to the file and committed to the local repository, this commit is an addition to the remote repository, which is actually one step behind us. So this basically means that you need to update these changes to the remote repository, which is still not updated. So to commit the repository to the remote Git repository, we will type it push origin, where our origin is main. So type main and press enter. As we have freshly installed Git Bash on this PC and the device is not authenticated yet, so it gives me a pop-up asking me to sign in. It asks you to give the authorization access so that a confirmation is done that you yourself is accessing your account. Else anyone could make changes directly to your repository. On clicking the authorize button, it asks your password. Enter it and press confirm password. Let's go back to the Git Bash. We can see that the push command has executed and it has uploaded, or we can say committed, our file to the remote repository at the given location. We can move back to the web console and confirm that the commits are performed. Moving to the project repository, we can see here that it shows a change performed currently. You can also see the commit message here, which we updated during the commit process. Here, if you move into the file, the changes that we updated can be seen. Just ignore the typo for the human spelling. So, this is how you make a commit in Git. First, making a local commit and then pushing the commit to the remote Git repository. I hope this has cleared your concept on committing a file in local and remote repositories. In our next lecture, we will see how you can add collaborators to your project repository. In this lab exercise, we will understand the collaborator role and how you can add a collaborator to your Git repository. So here, let's take an example. We have 3 developers connected to a remote repository. Developer 1 is the main developer, whereas developer 2 and developer 3 are the collaborators. Alright, if you remember, we have the repository My First Project created by user SkillCurve, which is the main user in our case and is the owner of the repository. And in addition, we now have 2 developers, Samia Bashir and Shuaib Siddiqui. These 2 will be the collaborator in our case. This means that the owner, that is a SkillCurve, will provide access to the other 2 developers, and then developer 2 and 3 will be able to get the updates on the repository available to them. Let's move on to the GitHub Web Console from the owner account, that is SkillCurve, and see how we can add collaborators. Here we are at the Web Console. We first move to the home screen of the project repository. Next, we move on to the settings. Here are the settings for the project. Then we go to the Manage Access tab. I have already added the password, but when you come to Manage the Access tab, it asks you for a password. Okay, so we go to the Invite Collaborator option and search for the collaborators. Like our first collaborator username is Samia Bashir. So we search for her. Here she is. Let's send her a request. Once you add, you will see a pending invite. This is changed to collaborator status once when the invited member accepts the invitation. Next, we invite another collaborator with username Shuaib Siddiqui. Here he is. Let's add him as well. Now you can see here that we have invited both these members as the collaborators. Once they accept the request, they can add, edit and make revisions to the repository they are given access to, meaning that they can work as a collaborator in the repository. I hope this makes your understanding clear on how to add a collaborator to the repository, and in the next lab session, we will see how a collaborator can accept the request and start to commit the files. In this lab exercise, we will look at how any invited collaborator can accept the collaborator invitation and update revisions of any file in the repository. Here we are on the developer 3 PC with the Git username as Shuaib Siddiqui. Whenever any collaborator is invited, the user is notified through an email. Here is an email received by developer 3 when invited. It can be seen in the description that SkillCurve have invited to collaborate on the project named My First Project. So the user can view the invitation by clicking here. Then after reading all the provided information, collaborator can accept the invitation. Once the user joins as a collaborator, he will then have full access over the repository. After accepting the invite, Git redirects you to the repository homepage. After moving to the activity sheet, it can be seen that developer 3 can now edit the files, but we will leave it for later. If we see at the developer 3 home screen, we can see that there are no repositories created by him, but he has a project in his repository. Let's move on to the developer 2 PC with username Samia Bashir. She has also received the same email for collaborator invitation, so the initial process for accepting will be the same. But before moving to these similar steps, let me show you one more thing. Here is the developer 2 GitHub account. If she goes to the search bar and search for SkillCurve and go to the same repository like this, She can see the repository as it is publicly available. But when she goes to the activity sheet to edit it, she can edit this file. But she cannot directly commit the changes to the same repository. Instead, she will have to propose the changes. This is because she has not joined the repository as a collaborator yet, and she is viewing the repository as a public user. Let's go back to the invitation and see what changes occur when she joins as a collaborator and then tries to edit the file. Now she have accepted invite to be as a collaborator, and here if we go to the activity sheet and make some changes, so developer 2 adding her self information in the activity sheet. And after that adding a commit message. And here the point to notice that the option which was previously proposed change is now changed to commit changes. So this means she can directly change the file in the repository. So this is how a collaborator can accept the invite and commit some changes. In our next lab exercise, we will see how a developer as a collaborator can get the files in their local repository and then commit changes to the remote repository. In this lab exercise, we will see how you can pull a repository to your local PC as a collaborator, perform revisions, and commit the updates. Here we are at local system of developer 2. I have created the folder with the name version control course developer 2. This will help you understand that we are currently at the local system of developer 2. Let's move into the folder and start Git Bash here. I will check for my username and email settings if they are assigned to my Git configuration. So typing git config -- global user.name must show my username. Alright, here it is good to go. Next we will see the email address. That's fine as well. So let's move further and start pulling the repository from remote. So to get the repository on your local PC, you must have the repository link, which works as a path for Git Bash from where to extract the repository. Here is the repository for skill curve. I will go to this repository and copy the HTTPS link. Coming back to the Git Bash, let me just move the window a bit so that you can see at the background when the files are pulled. Okay, so we write in git clone and paste the link here. Press enter and you will see the cloning starts. Remember that you can also clone the project if you are not a collaborator, but in that case you won't be able to commit the changes directly to the main branch. In fact, you can make all revisions in your own repository where you have cloned the project. Alright, so let's do some work on the repository. First we need to move into the repository folder, so I will write cd my first project. Right now I am interested in looking the logs of the repository. These are the logs. And here you see, this is the last commit I made when joined the invitation as a collaborator. It worked. But my email ID cannot be tracked over here. This is because all the changes you make from the web console directly are not trackable easily, as compared to commits made through local PC using Git Bash. Let's move to the file and open it so that we can make some changes and commit it. So here I will add a next row to the sheet. I am assigned a task to actually review the web template designed by John. And my deadline is October 31st, 2020 and status is in progress. Okay, saving the file and moving back to Git Bash. Here I will check the status and so for that write git status. And you see it shows in red color that the activity sheet is updated and ready to move to the staging area. The green status of the activity sheet above is because I made a change to the file previously before the recording of this lab session and moved to the staging area but did not commit. So not to worry about it, just focus on the red status of the activity sheet. So we will add this modified file to the staging area to later move to the local repository and then to the remote Git repository. The dot after the git add will move all the files to the staging area. This time I will use the name of the sheet, which is activity sheet. But here you see it gives an error. This is because you cannot type the name with spaces directly. We use a backslash before each space in the file name. So I will rewrite the command and add backslash before space. You see, it executes and without any error. Now when you check the status, it shows that the file has been moved to the staging area and is ready to commit. Let's commit it with a message. When I press enter, it shows one changed file and one insertion. We have just added from staging area to local repository. I will see the status, type git status. You can see nothing is left to commit. The important message is that our branch is ahead of one commit. This is because we are working on the main branch and the main branch is not updated but our local repository is updated. So it detects that change and notifies you that you are ahead of actual file status by a factor of 1. Now I will move it to the remote repository. So for that write git push origin main. Pressing enter will push the files to the remote repository just like this. Now I want to check the logs. So here you can see that we added the status for web template review this time as the commit is made from the git bash on a local PC. It also shows the complete tracking information with ID and email. Let's go to the remote repository and check for the changes there. So here in the activity sheet, you can see the added row on serial number 7. Coming to the history, you can see the commits history here as well. These are the 2 commits made by me. So this is how a collaborator can make changes, perform revisions and commit to the repository from local PC. I hope this has cleared your concepts on this topic. In this lab exercise, we will see how to add a commit to resolve any issue or to notify the team member about the changes to be made in the project. Here is the developer 3 logged in as Shoaib Siddiqui. Let's say he is the project manager. And he goes to the activity sheet and sees that something was updated previously which he does not need. He does not want the status for web template review. So he comes here and comments by mentioning the developer to that remove the task for web template review. Once the comment is made, the user is acknowledged about it through email. So this is how any team member can make comments. In the next session, we will see how to respond to a comment and perform some executions. In this lab exercise, we will see how to respond to a commit and perform the required task. So here I am the developer too. I have received an email that my project manager has committed on the activity sheet. So let's check it out. Here I can see the commit message and then I can view it on the GitHub. Here I see that I have to remove the web template review task that is mentioned in the sheet. Likewise, anyone can commit on a particular code or electronic document to remove or make required changes. So what I will do is go to my local PC and start git bash, and after making changes, commit it back. Here I can make the changes directly on the web console as well, but that will not leave footprints to easily track who made changes. So the best practice is to always perform revisions from local PC using the git bash. Let me go to the activity sheet here and edit the file. So here I will delete this last line and save it. I will make one more change to the file, open it quickly and add a dot here. You will get to know later why I am doing it. Now starting the git bash, I will see what's the git status. Here we see the red color, which means changes are done but not added to the staging area. So we will do it using git add command. So it is now added. Checking again the git status. Here it shows the green color text, which means the file is moved to the staging area. Next, we will commit the file to the local repository with a message as deleted the web template review task. Now we will push the file to remote repository. So for that, we write git push origin main. Main here actually is the branch name. So after you execute this command, it starts pushing the files and it is done. Let me switch to the web console and see the changes there. So we can see that the changes that were mentioned in the commit are now updated. Okay, so moving to history, here was the commit. I will go here and reply back to the manager that I have performed the assigned task, removed the web template review task. So this is how anyone can commit and assign a task. And we have seen how we can perform the changes as a collaborator and do the needful and commit back the file using git bash and then respond to the commit. I hope this has given a clear understanding of the concept. In this lab exercise, we will look at how to pull the changes or updates from the remote repository. Purpose of pulling here is to let you know that you are up to date with the remote repository so that if any of the team members has made any revision to the source file, that can be reflected in your local repository. Here we are on the skill curve local PC, that is the developer 1 in our case. Just to recall previously, he gave access to 2 collaborators, and one of them, the developer 2, with username Samia Bashir, made changes to the repository. That was made from the developer 2 PC itself. So now we will first check if we have those changes with us. First we check the status, and here you can see that it shows that our directory is clear and nothing to commit means that the system has no new files that are present in the staging area or in the local repository. Next we check the Git log, and we can see all the log history for the repository. If you recall, developer 2 committed some revisions, but that can't be seen over here. Why so? This is because the local repository is not up to date. So we need to update that first. To get the changes in the remote repository updated in your local repository, we write git pull, and you see that the command executes. Let's now see the status, that where we are. So there is nothing to commit. Next, I will see the logs. Notice here that now the changes made on the remote repository reflects here in our local repository. In this lab exercise, we will look at how to create a new file inside the repository from the local PC and push it to the remote repository. I will create a new document naming it as a list of stationery. Open it with the editor and let me create a list of stationery items. This is my list of stationery items. Now I will save this file. Now we come back to open the Git bash. First, I will check the status. You can see it detects the newly created file and labels it as untracked. And if you are interested to add it to the repository, it needs to be added using the git add command. This is why I recommend using the git status each time you use git bash, as it helps and guides you on what to do next. So I will write git add dot. This will add all the files in the folder that are updated to the staging area. Again check the status. So here this time the color is changed to green. The file is added to the staging area, and next we need to commit it to our local repository. So I will write git commit -m and the message as added list of stationery. You can see one file changed and 8 insertions. This is because we added 8 rows to our notepad file. Now I will push this file to the repository and in main branch origin. Here you go. The file is uploaded to the repository and it shows the HTTPS location where the repository is saved. Let's move to the web console and check if the file is available there. We go to the repository files and here is the list of stationery items available. In this lab exercise, we will look at how to create a new repository for any project. This is a project folder I have with me. It contains a code for a calculator project coded in C++ language. Let me open it for you. Here is the code you can see. Next, we will run the git bash. Here you can see that the current working directory is the desktop. You can also check it using present working directory command. But if you see here, the code files for the project is present in D drive and our git bash is pointing in C drive. So we will have to change the directory so that git bash works in the required folder, that is D drive and the calculator folder. To do this in git bash, we write cd capital D colon and execute it. This will move us to the D drive. And next, inside this folder, we need to move to the calculator folder. So now if I check my present working directory, it is the same as that I need to begin. The other way to directly start your git bash in the required folder is that you go to that specific folder, right click and start the git bash. Alright, so we are in the correct folder. We now need to commit all of these project files to a new repository. So for that, we will first need to create a local repository and then create the remote repository to push local repository to GitHub. First, we will create an empty repository. For that, we will use git init command. It has initialized the empty repository. Next, we will see the status of the repository. Type in git status. Now, this shows that there are these listed files which are untracked. And we need to first add to them and commit to the local repository. So we add using the git add dot command, as we want all our project files to be added. If we again check the status, we see that all these files are now added to the staging area. For instance, you have added all files to the staging area for commit, and later you realize that you do not want to commit some of the files so far. So for that, we use the rm command. For our case, let's say we don't want makefile.win to be included in the staging area. So we will write git rm -- cached and the file name, which is makefile.win. So now, if we see the status, all the files are still in the staging area, but the makefile.win file is removed and is untracked. Let's again add the files. So we have all the files in the staging area. We can now commit the files to the local repository. So I will write git commit -m along with the commit message like initial commit for calculator project, console. Alright, so the commit is successfully made. This is how you create a local repository. In our next lab sessions, we will look at how to move this local repository to the remote repository. In this lab exercise, we will see what Git Ignore is. There are cases where a developer or any team member may have some files, maybe a log file or any sort of file, which they don't want to be committed to the local repository or to the remote repository. Usual practice of most of the developers is that they create a log file to keep some records for themselves and not to share with others. This can be done with the help of Git Ignore command. Let's see it. For this, I will create a new empty text file. Write torch.txt. This will create a new text file for you in the present working directory. Let me add some text into this file. Maybe something like I have created a new project for the calculator console. I have created this file for my own purpose and I do not want to share it with others. But the file is present in the same folder, which is a part of local and remote repository. To ensure that the files are not committed, we use the Git Ignore function. It is basically a type of list in which you add in the names of all the folders or files that you don't want Git to commit either in local repository or in the remote repository. So I will create a .gitignore file. The file is created. Let's see how we added this file to create an ignore list for our Git to ignore the files that we don't want to commit. Just write the name of the file with its extension which you want Git to ignore committing them in repositories. I will write in log.txt and save the file. Now let's add the .gitignore file to the local repository. For that, I will write git add dot and check the status. Here you can see that we added two files in our present working directory, the log.txt and .gitignore. But it reads the ignore list and does not cater the log.txt file. Reason being that it is placed in the ignore list. In the same way, you can also add a complete folder to the Git Ignore list. Let's create a new directory with the name dir1. Also, I need to add a text file over here. Let's name it as activity1. Adding in some random text and save it. Now I will go to the .gitignore file and add this folder name that I want to ignore. So type in /dir1 and save it. I will create another directory with the name dir2. Inside this, I will create a text file with the name activity2 and write some random text in it. Alright, now let's add these changes to the staging area using git add dot command and see the status. So you see, I have created two directories and changed the .gitignore file. But Git has only added the dir2 and the gitignore file. The dir1 file was not added because we have added it in the ignore list. Now we can commit these changes to the local repository, and for that we will write git commit -m and the message as initial commit. I hope you have got an understanding on how to create a list for folders or files for Git to ignore them while performing commits in the repositories. In this lab exercise, we will look at how to create a remote repository from the local repository. Here is the same local repository we created for the Calculator console project. We will move this local repository to the remote repository. Let's see how we can do this. For this, we will go to the console, create a new repository here, let's assign a name as Calculator Console. I'm okay with the public settings. Here are some options. Git Ignore we have already added, so I will create the repository. Once you create a repository, this page appears. Here are the three options for setting up your remote repository. As we have already created a local repository and we need to push that repository to the remote repository. For that, I will copy these lines of code and execute them one by one. So the first line of code adds the remote repository to your system, referring it to the HTTPS link. Next, we switch the branch to main, where we will push our local repository. And finally, we push it to the origin main in our remote repository. Let's move to the remote repository homepage and see if the local repository is committed here. And here you can see all the files are available, but the dir1 folder is not present. That is because we added it to the ignore list. It is present in the local folder as a simple folder, but not in the local and remote repository. This is how you create a remote repository from a local repository. In this lab session, we will look at the concept for the branches in Git. A branch in Git is simply a lightweight movable pointer to one of these commits. The default branch name in Git is master. As you start making commits, you are given a master branch that points to the last commit you made. Every time you commit, the master branch pointer moves forward automatically. We have created this new Calculator console repository, and for this we will create a new branch. So why do we need a branch? Actually, whenever you add features to your project, or if you have a collaborator to your project who wants to test and add a new functionality to the source file, the member first makes a new branch, names it according to the feature they want to add in, and then start working on that new branch. Later, when they have done the testing and are satisfied with the performance, the later created branch can be merged with the previous one. For example, we have the code here for a Calculator console. And a developer in my team wants to add a feature for division in this calculator. Now there are two ways: either he can make changes in the same branch of the repository and commit changes, or he can first make a new branch and the feature test it thoroughly and then merge the later branch with the main. The later method is more convenient as it does not affect the main branch and members working on that branch. Also, there are fewer changes that your working code gets disturbed due to new feature experimentation. Coming to the Git bash to check all the branches you have in your repository and what is the current working branch, you write git branch. So the output says that there is only one branch with the name main, and this is our current branch. If you have multiple branches, then the Git bash will output the complete list and indicate the current working branch with green color. I hope you understand the concept of branches in Git from this session, and in the future lab exercises, we will look at creating new branches and merging them. This lab session is a continuation of our previous lab in which we learned about what is Git branch. As we discussed earlier, this time we are interested in adding a feature to our calculator project for a division function. And currently, we are in the main branch. So in order to add the new feature, I will have to create a new branch first. Let's create a new branch. We type git branch and the branch name you want. I will name it as adding division operation. Now our branch is created. Let's see now how many branches we have. We type git branch. Here we have 2 branches now and our current branch is still main. We need to edit our code for adding the division operation, and that change is to be done in our newly created branch. In order to switch to the other branch, we type git checkout and the branch name, which is adding division operation in our case. The name in the branch within this bracket also shows you the current branch in which you are working. You can also check the git status. And here you see the current branch is what we needed. Creating new branch copies all your working files in the new branch. So you do not need to start working from the initial point. This can be seen as I will add a new log text file in the newly created branch. I will name it as log2.txt. Here the file is created. Let me add some random text in this file. Now I will save it. Also, we make the changes that we need in our code, which is for the division operation. Adding the case statement for the division operation and changing it accordingly. Also add the user message for division operation selection over here. And then I will save this code file. Let's check the Git status. So it detects that the main.cpp file is modified. That is what we added the code for division operation. And it also detects an untracked file, which is log2.txt in our case. We will add it and commit in our local repository. I have added the files and let me check the status here. You see that the files are added to the staging area. Let's commit it to the local repository with a commit message. All of these changes we have committed are saved in the adding division operation branch only, If we check the current branch, it is adding division operation. Just notice the change in the open folder when I check out to the main branch. You see the log2 file just disappeared. Now this file is available in the local repository under the adding division operation branch. But as I have changed my working branch, it is not available here in the main branch. When I switch back to adding a division operation branch, you can see the log2.txt file again appears in the folder. Same is the case with the source code. Let me open it as we are in adding division branch. So this code must have the switch statement for division operation. And here it is in the code. Again, when I go back to the main branch, check out to the main branch, and open the source code, you can see here that the code does not have the division operation. So this is how multiple branches in Git works. I hope this session has cleared your concepts using multiple branches. In our next session, we will see how you can merge the branches after finalizing the features in the new branch. This lab exercise is the continuation of the previous lab session in which we learned about creating multiple branches. In this lab session, we will see how you can merge the newly created branch to the main branch after we are done with the features added to the new branch. To merge the branches, we must be in the main branch. Here in the bracket, you can see that the branch is main. Let's merge the branch, adding division operation to the main branch. I will move the window to the side so that you can see changes that occur in the folder. We write git merge, branch name that is adding division operation, and press enter. So you see that the merge is done successfully. log2.txt is added with 1+, which means it was a new file, and the main.cpp is the modified file in our case. If you notice in the folder, the files which were in the adding division operation branch are now available in the main branch. The log2 file is also now in the main repository. And if I open the main.cpp code, you can see that the division operation is now available in the main branch repository files. This can be seen here in the bracket that our current branch is main. If we see the git status, so our working directory is clean. We just need to push the changes to the Git remote repository. So for that, we will write down git push, and this publishes your repository to the GitHub. And here the file log2.txt and the main.cpp are updated and available in the main branch. If we had seen this branch list before merging, it will show you all the available branches in your repository. I hope this has cleared your understanding of how we can create a new branch and make feature addition and then merge it back to the main repository. In this lab exercise, we will see how git revert function works. The git revert command is a forward-moving undo operation that offers a safe method of undoing changes. Instead of deleting commits in the commit history, a revert will create a new commit that inverses the changes specified. In the Git bash, let us see the log. We can see 3 commits made in the repository. Let's say we do not want the division functions in our code we just added. This means that we need to move to the commit status where we performed the initial commit, which was the code without the division operation in it. So to revert back to the initial commit status, we need to first copy the commit ID. Then we type git revert followed by commit ID. Here is the console that asks you for a revert commit status message. The default message can be seen in yellow color that says revert initial commit. We can also change it as per our requirement. It also shows the changes that will be performed in the repository after you perform the revert operation. I will change the message to initial commit before adding division. Press escape and write here :WQ. This will write, save and quit the revert function and save changes. So it has removed the .git ignore file and dir2 folder. If we check the status, there are 2 untracked files. Because if you recall, we added these 2 files in the ignore list. And as the .git ignore list is now deleted, so the Git marks it as a new entry which is untracked. So let's add them this time in the local repository by the method we do. First git add dot and then see the git status. So these are added in the staging area. Let's commit them with a message as final commit. Check the status. These files are ready to be pushed now. So we push them into the remote repository. If I refresh the console page, you can see that the repository is reverted back to the commit ID we just wanted to be in. And if we see the main.cpp code, this is the code which is without the division operation. So this is how you can revert your repository back to whatever commit ID you want. I hope this has cleared your understanding of the Git revert feature.